Hi, this is John Lineval from John Lineval Tutoring, and this is Breaking Math. Some math, and I don't mean meth, problems based on Breaking Bad. Here's my contact information. If you would like to contact me, I'm always happy to hear from you by email or phone or text, or even postal mail if you'd like to get in touch with me. So here it is right there. What we're covering here, pizza problems. A few problems based on a scene where Walter White threw a pizza on the roof of his home after his wife wouldn't let him move back in. If you like this video, please don't forget to give this a thumbs up, subscribe to my channel, and subscribe to the, well, click on the little bell in the top right corner for notifications. All right, here's the pizza tossing scene from Breaking Bad.
Hey.
Hello?
Pizza.
Well, I'm making dinner.
Okay, I'll just put it in the fridge. It's even better the next day. Skylar.
Where Walter White isn't going to be let back into his house by his wife, even though he brought a pizza. And this is his reaction to being rejected. And the pizza did come from a real pizza place in Albuquerque, New Mexico, where I am right now as I'm recording this. Venezia Pizza, now known as Ginos. I will be eating there for dinner tonight. They specialize in unsliced pizzas. That's why the pie we see in the TV show isn't sliced. And this scene gives new meaning to the term hand-tossed pizza. Ha ha ha. It's easy to find Walter White's house. You literally just plug it into Google and this pops up. And so you can find where he lives or where the character lives. The real life owners of the house made some changes because they were tired of people actually coming and tossing pizzas onto the house. So you can see there's an iron fence out here. You can also see that they've put a much more pizza resistant metal roof on top of the garage and on top of the whole house so the pizzas will slide off. And you can see security cameras in use, and there are some other signs that say take your picture from across the street and lots of other things like that. So here we go. And you can see the orange traffic cones that they put there so you don't park in front of their house. But you actually understand why they're doing it when you can see here's the New York Post article where people are still tossing pizzas onto the Breaking Bad home. And so the woman who owns it is putting up a fence because fans of the AMC show can't stop recreating a messy scene. These people are vandalizing her house. It's just constant vandalism. It's been, well, that was 7 years since that episode aired. And so that's been about 2 years. Okay, it's been 9 years. She's really kind of getting tired of that. So, uh, anyway, I guess the takeaway there, or delivery, is please don't throw pizzas on top of this nice lady's house. Okay, anyway, back to this. The owners did make some changes. You can notice the new roof. And let's just say the homeowners could have used a different solution. Let's say the current homeowners decided to give in and take the fun out of the pizza tossing by roofing the entire house with pizza. That would lead to some fun SAT problems. How many Ginos, formerly Venezia pizzas, would you need to cover the whole roof? You can cut the pizzas to fit the roof. They don't have to stay round. How much would that cost? Well, according to my Google research, a party-sized pizza from the closest location, San Mateo, not the Salt Yard, would be $27 per pizza plus a $3 delivery charge. Don't believe me? No problem. See, it says $27 for a 24-inch party pizza. And there's a $3 delivery charge if you go to order online. So here we go. And also, an important piece of information is Zillow tells me that this house is a 1,910 square foot house. So that gives us an idea of how big the roof must be. So, and since we can tell that it's $27 per large party pizza plus a $3 delivery charge, that's going to be $30 per pizza, not including the tip. So let's do the simple math. I call it simple math because it's not really a good approximation of reality, but it'd be a moderately hard SAT or ACT problem. Remember how I just showed you 1,910 square feet is the square footage? That's just the floor space. Roofs are pitched, so that means the roof is actually going to take up a bigger area than the floor space, the space that you would walk on if you were actually walking around the house. And however, since the place is only one story, the floor area is just the same as what would be the area of the roof if the roof were completely just went up to the very edge of the wall, didn't overhang the wall, and were completely flat. But then it would not be as good of a wall. Not a wall. Wouldn't be as good as a real roof because it wouldn't be pitched, rain wouldn't come off, pizzas wouldn't slide off. Ha ha ha. All right. So we know a party pizza has an area of A equals pi r squared. And since it's 24 inches, that means the radius is 12 inches, which is conveniently 1 foot. So 1 foot squared times pi is pi squared feet. So we divide the 1,910 square feet by pi square feet. Therefore, we need 1,910 over pi. So we just go 1910, and then we divide that by pi. All right, so you're going to get, well, here you get 607.97. I got 608.28 because I used 3.14. So if we do 1910 over 3.14, we get 608.28. Either way, okay, so you're going to need 608.28 pizzas. Pizza from Ginos costs $30 per party pizza. So then, I would make that 609 because you can't order 0.28 of a pizza. So we go 609 times 30, 18,270. I would suggest that you round it up to $19,000 for a driver tip. And as I said, the square footage of a house deals with the floor space, not the area of the roof, so it's going to be greater, than the floor space because it's pitched. So let's look at the ways the SAT or ACT could make this problem more difficult and also more accurate. So one of the problems that we have here is that we assume the roof has a very shallow pitch to the point that it's actually negligible. We can just pretend there is no pitch, that it's a completely flat roof. Now, the problem with that is that roofs are designed to make it very easy for rain, snow, and pizzas to slide off so that the roof doesn't get overloaded and collapse. And in all seriousness, any kind of precipitation that accumulates, water, snow, anything that might get up there, ideally you want it to roll off because the roof can only support so much weight and you don't want it to cave in. So that's why they all have a slant or a pitch, so the top of the house isn't just the top of a box that's parallel to the floors and most of the room ceilings. The degree formed by the plane of the ceiling / floors and the actual roof is the pitch. If a roof has a 30-degree slant, the length of the roof is going to be twice the height from the ceiling to the top of the roof. So if this is 30, 60, 90, we can see this is x, this is 2x. The idea, this is twice this. But what if you only know this side here, the side that goes from the edge of the roof to this center point, which also lines up with the peak of the roof? Well, it's simple. This is x square root 3, so you would divide it by root 3 and multiply by 2. Because you divide by root 3, you get x, multiply by 2 to get 2x. So this is going to be 2 over root 3 times the length of this side going from the edge of the roof to directly under the peak of the roof. So you would need the area of each roof triangle because if you look at the top of a roof, you can see that the peak would form 4 different triangles. It's going to form 2 pairs of identical triangles, assuming that the house is probably rectangular. It's either going to be a square or a rectangle. If it's some other shape, fine, then you're going to end up with a different set of triangles or something, but most houses are rectangular. So you can see that the garage, for example, forms a triangle where the base is the edge of the roof and the height goes from the middle of the edge to the peak of the roof. So if you see, remember the garage, this guy here, you can see there's a triangle, there's a peak, right? Okay, so we know that it's going to go like this. let's assume the garage is 25 feet by 25 feet. That's a pretty reasonable estimate. Then this half is going to be 12.5. It's 25 over 2. And let's assume that this is 7.22 feet. Why? Because I'm cheating a little bit, because this is basically 12.5 divided by square root of 3. Then we know, oh, okay, this is going to be very close to 30, 60, 90, if not actually 30, 60, 90. And so then the hypotenuse, if you do the math, you can go, all right, 7.22, multiply that by 2, you get 14.44. If you don't believe me, hey, no problem. We can do 12.5 divided by, all right, we'll put a parenthesis, square root of 3, end parenthesis, boom, we end up with 7.216. We'll just round that to 7.22, or we can just multiply it by 2 as is, and you're going to get 14.43 because of my rounding. That'd be 14.44 because it's 7.22 times 2. All right, so the floor part, that's what I'll call this, or the ceiling part, if you want it to be 12.5 feet, the pitch is 30 degrees. That makes this 14.44 feet. That's this here, the 2x side. Okay, so then you find the area of each triangle and multiply by 4. Since we know this is 14.44 feet, becomes the height of each triangle. So that would be this here, going from here to here. That's the height. That's 14.44. So then you're going to multiply that times the area. Okay, well, we know that that's 25 square feet because we know that it's 25 by 25. So if we're looking at this, we're going like, meh, meh, meh. Okay, from one edge to the edge, which you can't see, that's 25. This is 14.44. Oh, here's some spam on my thing. All right, don't need bankruptcy relief center. Thank you very much. Okay, so then we can just multiply that. Since we know the area of a triangle is 1/2 base times height, then we know it's just going to be 1/2 times 14.44 times 25. Since it's a square, we'll multiply it by 4. So that's going to be 4 such triangles. So it's going to be 4 times 1/2, which is, of course, 2. And then 2 times 25 is 50, so we end up with 50 times 14.44, which is 722. And again, if you don't believe me, fine. 15 times 14.44 is 722. Okay. So the two sides will have a ceiling part of 12.25. All right. So let's say the area of the non-garage part of the house, the part that people actually live in, is going to be 1,910 square feet minus 625. 625 is 25 times 25. So 25 times 25 is 625. All right. So then we subtract that. 1910 minus 625 is 1285. Okay, so we got 1285. And then let's divide, let's say it's a rectangle, and that's going to be divided by, okay, that's 1285. We're going to divide by 25. All right, so you get 51.4. 12.5 times 51.24, sorry, 51.4. Okay, so 1285 over 25 is 51.4. So two sides will have a ceiling part of 12.5 feet, which, just as the garage did, which makes the height of the triangle 14.44 feet, as we already just discussed. So we have two sets of identical triangles, because you can see that two of them are going to be just like the garage, and then two of them are going to be wider. So besides the triangles with the height of 14.44 feet, there are triangles with a floor length of 51.4 over 2, because the whole thing is 51.4 feet long. So we're just going to divide that by 2, which makes the hypotenuse 51.4 times 0.5 times 1 over square root of 3 times 2. So it just becomes 51.4 times square root of 3, or sorry, 51.4 divided by the square root of 3. The area of each triangle in that pair is going to be 0.5 times 51.4 over 3 times 25. So the pair, you can just multiply that by 2. 2 times 0.5 is, of course, 1. So it's just 51.4 over 3 times 25. So we have, okay, this is 51.4 over 2. This is going to be 51.4 over 2 divided by square root of 3. And then this is going to be 51.4 times 1 over square root of 3. So basically, all right, each triangle in each other pair has a base of 51.4 times 14.14 times 0.5. So the pair has a total area of 51.4 times 14.44. All righty. So now for the grand total. So the total for the non-garage area roof areas is 51.4 times 14.44 plus 51.4 over root 3 times 25, which is 51. We just factor out the 51.4. That's going to be 51.4 times 14.44 times 25 over root 3, which this actually taken to 2 decimal points becomes 14.44. So it's 51.4 times 14.44 plus 14.44, 51.4 times 28.88, which is 1,484.432 square feet. And then we add that to the 722 square feet needed to roof the garage. We get 2,206.432 square feet. Dividing by pi square feet per pizza, we get 2,206.432 over 3.14, which is 702.68 pizzas. So we'd have to order about 703 pizzas. Well, we'd have to order 703 because they're not going to sell you 0.68 of a pizza. You know, say, well, I need a little tiny bit more than 2/3 of a pizza. They're probably going to say no unless they've got one they're going to throw out or something like that. Anyway, so just order 703 and you'll have a little snack left over. So 703 times $30 is $21,090 is what I'm trying to say. Okay, so that's 703 times 30, $21,090. And all right, I would suggest you round it up to $22,000 so the drivers get a nice tip. And it makes me wonder, would they use a semi, a dump truck, or just relay using cars? Maybe Jesse Pinkman could get another job, deliver him in his Monte Carlo here, the Captain Cook license plates. All right. And one thing that I want to do before I ask you about whether you found this video useful is I want to show you, let's find out what the average cost of roofing a house is using real roofing materials, not pizza. Okay, average cost of roofing a house. Okay, so the average cost says, okay, all right, the average cost of a new roof is between $4,707 and $10,460, depending on the roof size and materials used. A 2,000 square foot asphalt roof costs between $3,600 to $10,800, while a metal roof costs between $8,000 to $24,000. So, all right, so if our friends here in Albuquerque had decided on pizza instead of the metal roof, it might have been a little bit cheaper, depending on whether they got an expensive one or a cheap one. But on average, it looks like the pizza roofing would be twice as expensive and not really that effective since it would attract vermin and stuff like that, or you got some really, really hungry Breaking Bad fans, they might come and eat your roof. So let's not do that. Anyway, did you find this video useful? Please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? Well, it's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours. That's 240,000 minutes of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time, and I don't have anywhere near 1,000 subscribers. For the same reasons, you're not only welcome, but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos, and I reserve the right to delete comments, rather. I reserve the right to delete comments from and block those who specialize in destructive criticism, trolls, things that are off topic, spammers, disturb people, stuff like that. Anyway, thanks for watching. Hope you have a good day. Bye.